So this is the sum up lecture for the module 1, which is the introductory module on supply chain management concept, and the objective of this module sum up is to review some of the basics that we cover in this module in order to be sure that you are comfortable with everything, and so you can step with the next module. Be sure that if something is not clear, to review material or to reach your instructor, and be sure that there are no doubts before step to the next topic. So first, we start by defining what's a supply chain and the concept of the supply chain that you see depicted in these slides. In particular, we define the supply chain as a network of facilities that produce raw materials, transfers them into intermediate goods and then final products, and deliver products to customer through a distribution system. So in this definition, we analyze and we introduce all the main components of the supply chain. So a network of facilities that produce raw materials, transfer them into intermediate goods and then final products, and deliver products to customer to a distribution system, which means that we are addressing the make part of the supply chain, the source part of the supply chain, and then delivery part of the supply chain, which are then the main processes that we will have presented later on in the course. More in detail, I have shown you like the different components on the supply chain. So we'll start with the end customer. The end customer is satisfied by something which is like produced mainly by what is called the focal company, the main producer, that to produce needs first-tier supplier and second-tier supplier that are supplier of the first-tier supplier, and the supply network, as it is called, gives the focal company all the material components and services which are necessary to produce. Once produced, the company addresses distributor and retailer, which forms the distribution system in order to, let's say, arrive to the end customer, to bring in the end of the end customer the final product. In particular, we have highlighted that in the supply chain, these actors are interconnected by two types of flows. One is the information flows, one is the physical flows that we have just described. One is the physical flow that we have just described, and the other one is the information flows, which is the information that each supply chain actor transmits to the actor in the node before him in order then to manage and to properly shape the physical flow. Then we have analyzed the type of supply chain management decision that can be taken at the supply chain management level. In particular, we have distinguished three levels of decision. The first level is supply chain strategy or design. Supply chain strategy or design are focal company-driven decisions, so they are the decisions that are driven by the focal company, so the main producer in the supply chain, but that affect the supply chain structure and configuration, so the layout of the supply chain. Then, at the second level, we have supply chain planning decision, which instead are decisions that relate to single company processes, like how to share, how to design, how to implement a particular process within a company, but as this company is in a supply chain, needs to be aligned and shared with other actors. So the difference is that supply chain strategy or design are decisions that affect the structure and multiple actors in the supply chain, even if they are company-driven, focal company-driven, while supply chain planning are decisions that affect just a company, but need to be shared with other actors because they are all part of the same supply chain. At the end, we have supply chain operation, which instead are how to execute in practice single processes, which instead are single company focused because they just affect the operational activities of a single company. We have then distinguished different supply chain decisional objects, which are all the decisional nodes to which each supply chain management decision can refer to. In particular, we have distinguished between facilities, which are physical location in the supply chain where manufacturing is executed, inventory, which are all the raw materials, all the components, all the semi-finished good and finished good that are stocked somewhere within a supply chain. Transportation, which is everything that relates to moving stuff in the supply chain. Information, which are all the data and analysis that compose the information flows between actor and supplier, so all the actors that compose the supply network. We have seen that this is the combining supply chain management decision with supply chain decisional nodes, you realize what is called the supply chain decisional matrix, which analyze how different supply chain decision, for example a design decision, affect or impact or modify one or more different supply chain decisional objects. Then we have closed this module by talking about supply chain management processes. In particular, we have seen that the supply chain decisional matrix is structured in this way. So decision involves decisional object, but impact first process level. And we have closed this module by discussing which is a framework to analyze or to classify supply chain processes. In particular, we have seen that the reference framework for supply chain processes is the SCORE model. The SCORE model have been designed by the Supply Chain Council, and here is the link if you want to have more information about the Supply Chain Council. But basically, we have analyzed that supply chain management processes can be distinguished in 5 different categories: plan, source, make, deliver, and return. And again, I'm not like deep diving in all the characteristics of each of them, but here you can see the definition. We have discussed that the plan process is the planning that we have discussed that the plan process is the planning that refer to the whole planning of the supply chain, while instead then each specific supply chain process like source, make, and deliver can have its specific planning components, which is exactly what is depicted in these slides. So in these slides it's telling you that there is a general, the SCORE model tells you that there is a general planning process, which is planning the supply chain, so everything that relates to supply chain design and strategy. And then there are 4 different processes: source, make, deliver, and return. Source, make, deliver, and return can have their specific planning part. So here will be planning source, this will be planning make, this will be planning deliver, this will be planning return. In particular, I have highlighted the fact that at the executional level, plan, source, make, deliver, and return can be differentiated according to something. This something, so the differentiation in the execution of this process, is related to how the product is made. And in particular, we have distinguished 3 approaches to realizing product: make to stock, make to order, and engineer to order. Make to stock are all the products that are made, are produced to be supposed to be stored in inventories, like TV, like clothes, like pasta, and so on. So they are produced and stocked and delivered to the customer when they are requested. Make to order instead are products realized and customized in response to customer order, which means that the customer requests something and you realize the product after this request. A burger, a furniture, or a machinery. The customer asks for that and the producer realizes that. Engineer to order products are instead products that are designed from scratch after the product is requested by the customer. Example, a bridge, example, an helicopter, example, an airplane, example, a ship. So there are complex and unique products relied upon customer specification. What I was telling is that varying the nature of the product, and we discussed this in class, also the way in which I do sourcing, the way in which I do make, and the way in which I do deliver change and need to be adapted to product characteristics. All of these lead us to discuss the difference between push versus pull supply chain process organization, which is the first type of classification of supply chain that we have covered in this course. Let's see this representation. Let's start from the top, push system. You have a supply chain or a production system which is made by these three stages. The first stage is manufacturing of components. The second stage is manufacturing of sub-assemblies. And finally, the assembly in the final product of components and sub-assembly. In a push system, so if a production system works on a pull logic, in a certain period of time, can be at the beginning of the year, there is a plan. So, in the planning phase of the supply chain, there is a moment in which production planner make the production plan for each of the stages of the production system. So according to this plan, the manufacturing component stage will know which type of product will need to realize in each period, which type of sub-assembly will be needed to be realized in the manufacturing stages in each period, and which type of finished product will be needed to be assembled in this stage. So there is a plan which is made according to the forecasting. So here I have a customer, I forecast the demand, and according to the demand I know that I will need this amount of product, the finished product, which will need this amount of sub-assembly, which will need this amount of component in different period of time. This is made on a plan-based perspective. So I have a forecast of the future demand, and again, please remember also what we say before. In a push system, the inventory management is made according to future consumption. That's why I told you this before, because in this system we start from the future demand projection. So we start from the customer demand, which has been forecasted. According to this, different production plan are realized, in particular production plan for assembly, production plan for sub-assembly, and production plan for component. And once these plans are realized in an integrated way, so they are first realized at a general way, so you have your general production plan, they are then distributed and transferred to each stage. So it's just a disaggregation of planning. Okay? So each stage knows exactly what he has to do in every period of time. Once this system is in place, you can see that each stage can just implement its activities in an autonomous way if compared to the other one. So once a plan is in place, and it has been distributed to each stage can then just organize the activities independently from the other one. And that's exactly what happened. So it has a plan, it starts producing components, then once finished, they are put in inventory. Then it starts planning if he needs, when he needs components, it takes them from the inventory of components, it starts producing, and once realized sub-assembly, they are put in the inventory of sub-assembly. Then the assembly stage has a plan, follows plan, assemble a finished product. When he needs sub-assembly, it takes them from the inventory, and once finished, the final product is put in a final inventory to satisfy the demand. You see that in push system, each stage can work autonomously and independently from the other one, because all start with a general planning. So there is a general plan which is distributed to different stages, and then this stage go on autonomously according to this plan. This is a push system because the work, the supply chain flow go from the beginning to the end, so it is push.
material, a subassembly product are pushed along the supply chain. I start doing stuff, I put here, he takes stuff, he does stuff, he puts here, and so on. So there is a push flow. The flow of the supply chain, the product goes on because they are pushed from one stage to the next one, which is quite different from what happened in pull system. Because in pull system, you don't start from plan with something that is forecasted, something that is a plan, but you start with orders. Okay, so you have a customer that puts you order, and the supply chain or the production system need to satisfy this type of order. Again, your supply chain is made by, or your production system is made by these three stages: assembly of finished product, manufacturing of subassembly, and manufacturing of component. An order arises. It is first, see, okay, there is an order. Okay, do we have inventory to satisfy this order? If yes, of course, the finished product is taken from inventory and is given to the customer. If not, inventory tells the previous stage, okay, it's time to start producing in order to give me what the customer is asking. So from here, a request of inventory replenishment is issued to the assembly stage. So the assembly stage knows that he has to do stuff. To do stuff, he needs raw material. So he looks for raw material, he needs subassembly. So he starts looking at subassembly in the inventory of subassembly. Question: do I have subassembly to realize what I need to do? If the answer is yes, I still go in my activities in order to satisfy the customer order. If not, I need to issue a replenishment order to the manufacturing stage of subassembly. Again, and there is the same path. The manufacturing stage of subassembly start producing, and to produce, you need components. So you look at inventory of components, and he understands if it has enough components to realize what he has asked to do. If the answer is yes, he can realize subassembly that are put in inventory and take it by the assembly stage to realize the finished product. If not, he needs to ask to the manufacturing stage to realize components in order to be put in inventory that then they are needed to be realized, subassembly that are needed to assemble the final product. You see that in this case, the logic is completely different. So you start from the actual demand, and each stages work in reaction. So assembly start working because there is an order. Manufacturing subassembly start working because the assembly stage has told them that they need subassembly. And same for components. So components work when subassembly asks for replenishment of components in the inventory. So this is a pull system because the product flow on the supply chain or on the production system is not pushed from one stage to the other one, but is pulled by the final demand. So assembly activities are pulled by customer demand. Manufacturing subassembly activities are pulled by assembly request. Manufacturing component activities are pulled by manufacturing of subassembly request, and so on. And inventory, here, when I say look at inventory and they ask from the previous stage if they don't find what they are looking for. So inventory is replenished only if the level of inventory is not satisfactory to satisfy the demand. So not in function of future consumption, because there is not future consumption. There are not plans here. We are just order coming from the final market. So when there is an order, the system starts reacting. Okay, so without order, ideally, the system is not working. Because without order, there is no need to look here, no need to replenish this inventory, no need to replenish this inventory, and so on. So without order, the system is supposed not to work, when instead the system is supposed to react when a customer order arises. Pull system. The system is pulled by the customer demand. Now that you have seen this distinction, it should also be clear also this graph, because when we have talked about the different way to classify the production system according to the managerial perspective, now that you see the difference from push and pull system, you know also that this is not just the way to classify the system from a managerial perspective, but these different classes distinguish the production system according to the way they satisfy customer demand, and so they manage activities in terms of how they manage inventory in the production system. Because if we start from make to stock, as we have defined it, all the activities, engineering, purchasing, manufacturing, assembly, are realized upon forecast, which means upon plan. So it means that this is a complete push system. Each stage works according to plan, everything is put in inventories, final product is put in inventory according to future consumption. And then when a customer demand realizes, you are supposed to have all the inventory that is needed to satisfy this demand. While instead, on the other side, engineer to order are complete pull system. Because again, please remember that you start doing all the activities just after the customer demand has arrived. So the date of the order is here, and you start doing activities just after having received the customer request. This is a completely pull system because these stages works only if there is an order, if there is a customer demand. So the product flow in the supply chain is pulled by the customer demand. In between, you have what they are called push-pull system, meaning something in between. So more push or more pull system. So system that don't follow a specific logic, but they mix it. In particular, we will have like system like assembly to order, which will be more push oriented. They are push-pull system, but more push oriented because three activities are forecast based, so made according to plan, so follow a push logic, while assembly activities follow a pull logic. The assembly stage only works when the customer demand has been put. So it means that these activities are executed according to a pull logic, while instead engineering, purchasing, and manufacturing are executed according to plan. This is, exactly in between. So this is a really balanced push-pull system, because in make-to-order, engineering and purchasing are realized according to plan, so they are pushed by plan, while instead manufacturing and assembly are pulled by customer demand. Finally, we have a more balanced, a more oriented pull approach, which is purchase to order. In push-pull system purchase to order, the only activity that is executed on a pull base, so on a forecast base, is the engineering on the product, while instead purchasing of stuff, manufacturing of product, and assembly of product are made not according to plan, but according to customer order, so according to a pull logic. They only execute stuff if they have a customer request to be responded coming from the final market. Here you see some example. Besides the table, I'm interested in highlighting which are some example of industries that use this type of approach. So make to source system. So push supply chain or production system are groceries and clothes. Everything is realized to be put in the final inventory. So there is a big planning about clothing. They make the forecast for the summer season, the winter season. They start producing according to the different plan that they have. They all put in inventory. Then when it's time to sell clothes, you expect them to go to the retail store and find what you need, what you want, because again, that's the logic of a push system. you should maximize the level of service of the final inventory because everything has been made according to plan. When instead assembly to order, so push-pull system are typical of technology like notebooks, laptop. They have all the components that have been all manufactured. You just execute the assembly after the customer request has been put. Think about the business model of Dell. Make to order, so pull system, are instead car. The car industry, we already talked about car industry. Don't think that car producer just relies all the car in advance. When the dealership or when a distribution center or warehouse center ask the car manufacturer which is the level of demand that they expect and they want to be satisfied in a certain period of time, the car manufacturers start producing and assembly this type of product. Finally, this is quite intuitive, we already talked about that, stuff like houses, industries like houses, bridges, and the construction industries, helicopters, aircraft, ship, are made on a pull logic. So when the customer order arrives, I start executing from scratch all the activities from engineering to final assembly in order to satisfy in full the request coming from the customer.